Hey guys, and welcome to Lesson 19, Simplifying Rational Expressions. So first off, let's talk about what rational expressions are. So rational expressions are going to be something like this: x squared plus 5 over x plus 2. And what it is, why it's called a rational expression, it doesn't really mean it's really rational, rational like the way we normally use the word. It's more to do with a ratio, like a ratio expression. That's why it is, because you've got something over something else is a ratio of two polynomials. So that's what we mean by a rational expression. Over here, every time you do this, a kitten dies. The kitten doesn't actually die. The reason why I brought it up is because right here, this is going to be probably the most common mistake that people make with this. I'll wait till we get to a question like this to explain why, though. No kittens are going to be harmed in this. All right. So number one, um, so we've got a ratio, right? We've got like an x value or v in this one, something over something else, and we want to simplify it. So you can really think about this as being split up into two pieces, like the numbers and then the variables. So the blue part here, the numbers, I can really just treat that like a normal fraction, right? So if I say, okay, what goes into 30 and goes into 25? Well, 5 goes into both. So I'm going to rewrite this as, well, 30 divided by 5 is 6. And then 25 divided by 5 was 5. So 6 over 5. And I left this a little bit long because I'm going to have x's over on this side too. So one thing I'm going to do, though, this x squared term, I'm going to rewrite this for a second just to make a bit more sense. I'm going to rewrite this as x times x, right? That's x squared. That's all x squared is, x times x. And then the bottom, we've got just x. So now you can see that we've got two x's up top, one on the bottom. One of those x's is going to cancel with one of the x's on the bottom. So you can kind of think about it as just canceling x's like that, right? And what you'd be left with is just 6x over 5. The other way of thinking about this, let's just go back up here for a second. Let's pretend I wrote this as 6x squared over 5x. Well, remember your exponent rules from grade, hopefully, maybe you do. If you've got what you do if you're dividing your variables is you subtract the exponent. So what you'd have here is x to the 2 over x to the 1, so 2 minus 1. What you'd end up having is 6x to the 1 over 5. So same thing, right? So you can use your exponent rules too. So I just want to see, like, I usually prefer to kind of think about it as like canceling x's, but you can do the exponent rule too, like with subtracting. So that's also valid. All right, so let's do another one. Okay, so now I'm looking at the top here again, and we're going to say, okay, what goes into 18 and into 30? Well, 2 goes into it, but we can get a bigger number than that. 6 goes into both of those. So we can rewrite this now as, I'm just going to put like a long line because two things are going to go in there, but I'll put the numbers first. So 18 divided by 6, that's 3. 30 divided by 6 is 5. So that's it for the numbers. Now what we can do, you can think about this as writing like, this v squared. That's like writing v times v, and on the bottom I've got v times v times v. Two of these are going to cancel with two of those, and what I'm left with is 3 over 5v. And now another way of thinking about that, though, with the exponent, just subtracting the exponents, if we go from this step here, let's go 3v squared over 5v cubed. If you were going to subtract the exponents, what you'd end up with is 2 minus 3, that's negative 1, right? So what you'd have is 3 v to the negative 1 over 5. Now remember what a negative exponent means. If you have a negative exponent there, that means that it gets flipped. So if it's on the top, it's now on the bottom. If it was on the bottom, it would now be on the top. So we could rewrite this as 3 over 5v. Same thing. So you can do it however you like. You can think about canceling, or you can think about subtracting the exponents like you would do with the exponent law. So what I'm going to do for this lesson is I'm going to leave some of these for you guys, and then that's going to be your homework assignment. So I'm going to leave 3 and 4 for you guys. And let's do 5. Ooh, this looks dangerously like factoring, doesn't it? It's because it is. We got to factor in this unit. Okay, so what we want to do when you're doing when you're simplifying these things, step number 1 is you want to factor anything that you can. So that's step number 1. Always factor anything that you can. So if we factor this one, so let's rewrite this top as bracket, bracket, bracket. It's going to be a P and a P. And then I need to figure out what this number is and what this number is, right? So remember, the two numbers I'm looking for, they need to multiply to 3 and add to 2. So what about 3 and 1? And then this would be -3 and +1. And this is over P plus 1. Okay, so now here's the thing. The whole reason we did that was because if you just put that in brackets, hey, I've got the same thing up top as I do on the bottom. So they just cancel. And what we end up with is just an answer of P minus 3. Okay, so actually, I'm going to go back for a minute, though. I probably should have done this before. Now that we get a good grasp on simplifying, the other thing that we want to do for these questions is we want to state the excluded values. So what do I mean by excluded values? So we're saying, like, what is X not allowed to be? That's what excluded value means. So if you look back at our original question, you always look back to the original question. You're going to say, okay, what would X not be allowed to be? And what X is not allowed to be is going to be like what's going to make the denominator equal to 0. You can't divide by 0. If you try to divide by 0 in your calculator, it'll give you an error, right? It says can't do it. Or like you made a mistake, or yeah. So what would X need to be here to make this denominator equal to 0? Well, it would have to be 0, right? Because 0 times 25 would be 0. So the way you'd write your answers in the end here is you'd say 6x over 5. But then you'd say where, which we just kind of do with like a comma. You'd say x cannot equal 0. And that would be the full answer. Sorry, I should have done that at the beginning. I wish I would have. So now these ones too. So go back to your original question. And we're going to say, okay, well, what would x, or what would v, not be allowed to be? Well, again, if this was a 0 in there, that would be 30 times 0 cubed. That would be 0. So it's not allowed to be 0. So we'd say where v is not allowed to be 0. Cannot equal 0. And that would be my answer there. Okay. So make sure you do that too. That's the second part of doing these. So now that I have my answer here, P minus 3. Sorry for jumping all over the place. So P minus 3. I'm going to say where, and then I'm going to go back up here and say, okay, well, what would P not be allowed to equal? You always have to look at your original equation, though. So what would P not be allowed to be? Well, it couldn't be -1. If P was -1, then that'd be -1 plus 1, which would be 0 in the denominator. So where P cannot be -1. Sorry. So we'd say where P cannot equal -1. And that'd be your full answer. Okay, let's do 6. All right, so like I was saying before, what do you do there? You got 36 up top, you got like some stuff in the bottom. You always want to check to see, okay, can I factor something to make this work? So to do that, let's try to factor the bottom. Is there anything that I can factor out of the bottom? Okay, so with the bottom, I'm going to rewrite the top the same, so 36 over. I can factor out 6 out of that, right? 6 goes into 42 and 6 goes into 48. So I'm going to start out by writing, okay, 6 bracket, and I'm going to write what I have left. So this would be 7x minus 8, and then close the bracket. Okay, so now that we factored that, now I can simplify these things. I can simplify the numbers. So let's rewrite this now. 36 divided by 6 is 6. So this is going to be just 6 on the top. Over 7x minus 8. Okay, now though, we need to write, okay, what is x not allowed to be in this expression though? So we'd say where x is not allowed to equal. Now, what is it not allowed to equal? Well, like I said, you want to go back up to your original expression, but that's not as helpful. We're going to want to look at the second expression because we haven't canceled anything yet. So it's the same thing. So you want to go to the point before you actually like crossed anything off. Like we're not supposed to look at this last step here, right? It would actually technically work in this case, but you want to look at this case. So I'm going to say, okay, what would the denominator, or what would x need to be to make this denominator equal to 0? So anything I multiply by, like, I'm really asking, what would I need to make this bracket part equal to 0? So, like, what would make that equal to 0? So what I'm going to do is over here, I'm going to write 7x minus 8, and I'm going to make it equal to 0. So I can figure out what x would need to be to make that expression equal to 0. So you'd write x is equal to, and if you rearrange that, you'd have 8 over 7. So in my final answer, I'd say where x is not allowed to equal 8 over 7. And that'd be my answer. Okay, I'm going to let you guys do 7, 8, 9, 10 on your own. Make sure you factor everything that you can first, right? So looking at this one, how would that factor, right? You can factor out a 6 out of that. You can also factor out an n out of that. So that might be helpful. So make sure you factor those things properly. Let's go on to number 11. I'll give you guys a hand with this one. So like I said, what we want to do is factor these things first. They're not really much use to us when they're written like this. So let's factor the top. So I'm going to go brackets. It's going to be an n and an n. And the numbers I'm looking for need to multiply to 4, add to 3. So what about 4 and 1? And then this would be positive 4, negative 1. Okay, over brackets again. We got n, we got n. Numbers I'm looking for need to multiply to 20, add to 9. So what about 4 and 5? And both positive. Okay, so now that we've got to that point, we can see, well, I can cancel n plus 4 and n plus 4. And my final expression is just going to be n minus 1 over n plus 5. Notice that I didn't write the brackets around it anymore. Doesn't matter. I could have wrote the brackets again, but I don't really need to write them because I don't have anything beside them, right? I don't have like any numbers over there. So they're called implied brackets at that point. Okay, so let's say where. Now, what is n not allowed to be? Well, n cannot equal. I'm going to look back up to this point because before I actually canceled it, right? Before I actually crossed that stuff off. So maybe I'll just get rid of those. I'm going to say, okay, what would n need to be to make the bottom 0? So I'm asking, what would n need to be to make this equal to 0? And what would n need to be to make this equal to 0? And you can probably just kind of see from this one, you'd say n is not allowed to be negative 5, right? That was negative 5, that'd make that 0. And negative 4. So those are the two numbers that n wouldn't be allowed to be. Okay, moving on to 12. Actually, you know what? I'm going to let you guys go ahead and do 12 because it's pretty similar to the one we just did. Let's go on and do one of these tougher ones that you have to do a little bit more factoring. Okay, so let's do this one. So let's factor out what we can. Looking at the top here, I'm going to say, okay, well, I can factor out 8 and an x. So 8x, and I'm left with just an x plus 64 divided by the 8 that I took out. I'm left with 8. So that's what that looks like factored. Over. Now, this looks like it might be a little bit of a tough question because the number out front, the leading coefficient, isn't 1, right? It's some number. But we can probably make this a little bit easier if I just factored out a 2 first. You know, I could do the whole, like, it needs to multiply to 2 times that, you know, and then add to 30 thing. Like, that, it would work doing it that way. But it's going to be easier if we just factor out a 2 first. So let's factor out a 2. And then what I'm left with is x squared plus 15x plus 56. Okay, Now just keep going down. So let's write this again. So now I'm just going to write the top again. We've got 8x times x plus 8 over 2. And now let's factor this. So it's going to be an x and an x. My numbers I'm looking for need to multiply to 56, add to 15. So what about 8 and 7? And they both be positive. So now, perfect. I've got x plus 8 on the top. I've got x plus 8 on the bottom. So now what I can do is cancel and cancel. And I'm left with 8x over 2x plus 7. But we're not quite done because you can kind of see that these could still be simplified. So I can go 8 divided by 2, or, yeah, 8 divided by 2. So in the end, we've got 4x over x plus 7. And that'd be your answer. But then you'd say, where? Now, what is x not allowed to be? It's going to be the easiest if we look back to this stage here. Because we can see, okay, what would x need to be to make that equal to 0? What would x need to be to make that equal to 0? It looks like it'd be -7, so it can't be -7, and it can't be -8. And I just want to make it clear too that math is like, this isn't the exact order of things that needed to happen for me to get that answer. You also could have, simplified the 8 and the 2 at this point, right? Wouldn't have mattered. So it's going to be a little bit like, whoever's doing it, like the choice or whatever, the way they kind of like to do it. So more than one way to answer these questions. So I'm going to let you guys do 14 because it's like the one I just did there. And actually, that's it. I'm going to let you do the rest of the questions. One thing on 16 that I could see, seems like everybody forgets. Look at this bottom part here. If you factor it out at 10, you might be left with a difference of something. So just wink, wink, nudge, nudge. Difference of something, okay? All right, so I've got the answers at the bottom here too, so check your answers as you go. And that's going to be it. So I'll see you guys in the next lesson.